is started. Yes, perfect. Very good. So let me start again from our usual reference web page in my website. So you see the calendar. Today is the last lecture, and let's go to the links. I already mentioned to you that, and still I have to put a note here, that the red link was not discussed. I leave it here for your information. By the way, in my website, there is, because all of my lectures are given with the support of this kind of web-based tutorials. So in my website, you have also links for all of my lectures and of course, related to climate, there are many more lectures. So if you're interested, you can go there. But this one, I think it is particularly relevant to you. So I left it here. And it's relevant, but on the other hand, as I already mentioned, it will be discussed the next year. So what we do today is to try to complete our discussion by learning how we study usually the climate change impact on Earth. So we are learning the methods. Today, we are not making any specific reference to a particular disease. I already gave some examples like schistosomiasis, as you may remember. But today, when talking about the climate impacts on human health, we don't make reference at any specific disease because, as I said, next year, instead, you will look in another course, ecosystems, something like that. You will look in detail at specific diseases. And I was used to also to give a lecture on specific diseases, the red one here. But then we checked with the other teachers, there was an overlap. So I'm not going into the details of specific diseases. I am a little bit sorry for that because indeed, this is a subject where I learned a lot, but I also learned a lot on how to assess climate change impact on the human health. So I mean, it's fine. So let's click on climate change impact on health, and I have a PowerPoint presentation as usual, which is already here. Let me start it, and let me check if you can see it. Yes, for now. And if for some reason you see that the presentation doesn't advance, just let me know. Okay, I'm trying to keep an eye on it, but sometimes when I share the screen, because I need to share the screen to get it recorded in the video, sometimes something goes wrong, right? So let's hope that everything is fine. So this is the train of thought of today's lecture, but before I start, let me make a kind of resume of the take-home messages so far that I tried to convey to you. So the main take-home message is indeed to understand how climate and climate change in particular has an effect on the global health. And we learned that in doing that, specifically, if we want to refer to climate change, we learned that we need predictions of future climate. And we learned how these predictions are obtained through climate models. And we learned that there is uncertainty in these predictions. And we learned where to download the data. And in the last lecture, we made some examples of management of healthcare systems in order to minimize the impact on emissions and therefore on climate change. And we also viewed and discussed some examples of environmental risk proofed healthcare systems, hospitals. So we discussed about flood-proof hospitals, etc. And the discussion, remember, this is another take-home message, is extremely important because very often when we design structures for healthcare, like hospitals, it is extremely difficult, even for a specialist, to assess the exposure, the vulnerability of the structure to environmental extreme. Why it's difficult? For the obvious reasons that there is uncertainty. And therefore, sometimes these aspects are neglected, like it happened during the flood in Germany. I am involved now in a, not really a consultancy activity, may become a consultancy activity, related to a design project for a new hospital in Pesaro. And indeed, the new hospital is located in an area that is very close to a possibly flooded zone. The hospital is very close. And therefore, the big question is, okay, how the flooded zone, the possibly flooded zone was identified. Another question is whether climate change has been taken into account. And therefore, now we are looking with refined analysis to indeed the amount of the risk. So it is extremely important. But on the other hand, let's go to today's lecture. And what I want to do is to go through this index that you see here, step by step, by trying to get a logical connection during this train of thoughts. Okay, so first, we already learned examples. We discussed examples on how climate change may impact the human health. We learned that climate is a fundamental driver of our health for many reasons, which I don't repeat here. And we learned that our health is sensitive to the climatic extremes, like droughts, floods, like heat waves, windstorms, hurricanes. We already discussed it. Perfect. And, you know, it's important to try to understand how this vulnerability evolves in the future. We also discussed this. And, you know, basically, the human health is co-evolving with climate. And I mean, the dynamics of illnesses to which we are exposed, they evolve, and we get through immunization, through evolution, we evolve alongside with climate. So if you look at the body, at the internal body of people in different regions, in cold regions, for instance, against very hot regions, you see differences. You see differences also in the look, in the looking, in how the body is shaped, and you see differences in color, and of course there are differences into our internal structure. And this is the result of a co-evolution, and this co-evolution is governed by feedbacks. So climate impacts our body, and our body reacts, and in turn we have an influence on climate. This is why we say we co-evolve. Now, if you change the climate, of course, this co-evolution changes as well. So if the change in climate is slow, it's a very slow change in time, like it usually happens. Usually these changes are not dramatic. Usually they are kind of gentle changes, and therefore the body has the time to react. Not only the body, also the societal system has the time to react. Typically, we already discussed this, we react to climate change through migration. And in the long term, this is perfectly fine. If it takes centuries, the climate to change, there is time to migrate, there is time for the geopolitical organization to adapt. Of course, this kind of adaptation may generate wars, may require some blood to be, unfortunately, sacrificed, like the coevolution of health with climate. We may require, unfortunately, to adapt to illnesses, we may require to get immune against these diseases through, unfortunately, the loss of some lives. But again, if the process is slow, it's not really a big deal. And I mean, this is natural evolution of the Earth system. If the process is a little bit quicker, like now, because we observed how temperature is increasing. In the last 30 years, it has been a bit quicker, and it becomes more problematic. There is still a coevolution, but at the price of more tensions, more geopolitical tensions, and at the price of some health problems. So indeed, predictions for the future are extremely important to understand how we should get prepared. Indeed, there are several studies, for instance, that demonstrate that global warming impacted migration and impacted the geopolitical organization at the international level. Okay, that's fine. And then, you know, this subject, connection between climate and health, became more and more popular in recent years. Once again, keep in mind, global warming is 30 years old, a little bit more. We assume that it started from 1990, so it's about 35 years old. Our concerns about climate change, they are as well like 35 years old. Before then that, we were not concerned by warming. We were concerned by extremes, anyway, by fluctuations. So we have, in any way, get used to a climate that is changing, because climate was never stable, as we discussed. But, you know, recently there has been a renewed interest in this connection, because we see that now global warming is really progressing a lot. And you have to take into account that the literature here is changing every year. This is the third year I'm teaching here, and it's the third year I changed my lectures. And I needed to change it. And every year I check over the web. I check with the ChatGPT or any other form of artificial intelligence. Of course, I check the results. I read papers. Yesterday, for instance, this morning, I read another paper. And I put some of the figures from the paper in my slides. So just keep in mind that in about 2, 3, 5 years from now, what I'm teaching is already updated and the literature is flourishing. And just keep in mind that you don't have a textbook telling you how the system is evolving, how to cope with climate change. Is too early, and probably, you know, it's also probably too late for textbooks to keep the pace of the changes of our socioeconomic system that are so quick. That, you know, a book published 10 years ago is already old. So, I mean, I see that recently there are less and less books that are published. Okay, so let's try to understand what is the state of our knowledge. And first of all, what are the climate events that are more impactful on our health? We already gave some examples, but let's try to make a classification. And first, let's divide them in two big categories: non-traumatic consequences, non-traumatic impacts, and traumatic impacts. We usually believe that the traumatic impact is the most important. Actually, it's not like that. I mean, indeed, during disasters, during extreme events, there are traumatic impacts, but usually these are short-term effects that are not very relevant if we consider other non-traumatic impacts, which are related, I would say, mainly to mental disorder, mental stress, mental health. There are long-term consequences on the mental health of people, and these are difficult to quantify. I mean, traumatic accidents are very easy to be classified and identified, because people go into the hospital, of course, during the event and soon after the event. You know, this kind of trauma that are suffered in the long term, you know, they are more difficult to detect. But we learned that mental disorder and mental health is indeed very important. There are also other kind of non-traumatic consequences. We can mention the cardiovascular diseases and respiratory diseases related to air pollution and related, for instance, to extreme heat waves that are experienced by people. Vector-borne diseases, we don't talk about these, but I gave the example of the Lyme disease, for instance, and other non-traumatic conditions. And in doing this description, I already introduced another classification: short-term effect, long-term effect. And this classification will guide us in understanding what are the main problems. And let me give you an example that is becoming really an urgent issue. It's the climate anxiety. There have been a couple of, not a couple, many recent contributions on mental disorder caused by the anxiety by climate change, because climate change is in the media, is at the top of the agenda of international non-governmental associations and organizations. It's at the top of the agenda of many head of states. And also it's a controversial topic, as we learned. And therefore, you know, this is generating, especially in the young people, a kind of anxiety. And, you know, the movement Friday for Future, which is originated by real concerns about the future of people under this changing climate. You know, older people are more experienced. It's not just a much that older people don't care about what will happen in 2060. It's also the fact that older people, they have some experience. They already know that climate is sometimes bizarre, and usually, if they are more concerned, if they are more aged, they are less concerned. Also, another category of people that is usually not very concerned is the category of the people that live very close, in very close contact with the natural environment. These people are used to look at climate with a perspective that is more fact-based. So these people usually look at the extremes with a perspective, again, that is fact-based. People who live not so close to the natural environment instead tend to rely on the media, on the TV, on the social media, and any other media. And therefore, their perspective is more influenced by the mainstream that is broadcasted by the media. And therefore, it turns out that they are more concerned. Sometimes, you know, I like to talk to people affected by climate disasters. When I talk to people living in the natural environments, usually they say, yes, but this always happened and we are used. My grandpa was indeed flooded, like I'm flooded today. They are in a way more reassuring, more optimistic. When I talk to people that live in the cities, or when I talk to students, there is the opposite feeling. And therefore, I mean, this is really becoming a real concern, as it is proved by some surveys. And here I am mentioning a couple of them. The first was launched by Lancet. I will give a picture in the next slide. And this survey among about 10,000 young people in the age between 16 and 25 in 10 countries. I mean, they found that about 59% were worried or very or extremely worried about climate change. And 84% of them are at least moderately concerned. So it is an important percentage. And over 50% mentioned like anxiety. They felt like they were powerless with respect to what was going on. And some of them felt betrayed, like the information about climate change is manipulated in order to keep the people calm and accept the current evolution. So this generates a lack of trust, which is particularly concerning. And this may be an explanation for the fact that, in particular, young people, they don't take an active participation. They don't actively participate at elections because they feel like they are powerless. They feel like the information is manipulated and they don't trust the system. And this is a big problem because, you know, when people don't trust the system cannot work. And this is something that we should really address, take into account, not just dismissing it like, okay, Friday for Future, some people say, okay, let's them protest, this is not very relevant, they will grow up and they will learn that, yeah, I mean, we should not be dismissive with respect to these concerns gained by people, because they are motivated. Because if you look at the media, how they talk about future climate, I mean, it is something concerning. So either one is very solid and says, yeah, okay, I know that this is a bit exaggerated, but in order to be informed and in order to understand that it's exaggerated, you need to be informed. You need to, dissemination is very important. So the dissemination that we can do about climate, talking to people, and also you have a role in this, in the healthcare system, there is a role, and dissemination is extremely important because, I mean, we need to reassure people in order to, in a way, to protect their trust in the system. If the people don't trust the healthcare system, it's a problem. And if they don't trust the government, it's a problem. If they don't trust the police, is a security problem. And here I am also mentioning another survey in 2022 from the Office of National Statistics of UK. And this is quite relevant because UK is a country that is in Europe, is, I mean, it's quite similar to our reality. And this survey found that about 62% of UK people over the age of 16 are worried by global warming. And they are concerned that the global warming will affect directly them. And you see that these statistics are, I mean, deserve attention. And let me show you another slide, which is the result of the Lancet. This is a bit complicated to look on the screen, but this is the result of the Lancet survey, which is very easy to summarize, actually. Basically, you see that for each countries, first there is the first two lines on the top are all countries. And you see that for each country, you have two bars. The first bar is light blue and is representing the percentage of people who feel impacted in their day-to-day activities, on their functioning, like people that are impacted for their physical activity. This is something that is well known. So we know, for instance, and I have a slide later on about this, we know that in many countries, people are losing hours of physical activity because when it's too warm, when it is too hot, they cannot take a physical activity. Okay, we could say go in a gym, but not in all countries they have a gym available with air conditioning. So the result is that, particularly in the countries with low resources, they lose physical activity. So the light blue bar, upper bar for each country, you see the percentage of people who feel impacted. And then the second bar at different colors, basically, if you look at the dark red, light red, and yellow, this is the percentage of people in each country. That is, you see, dark red, extremely worried, light red, very worried, and yellow, moderately worried. And you see the in different countries what is the progress. You could see some patterns here and there. So, for instance, Philippines, a lot of people are worried. Why? Because they are worried by sea level rise. And another country where we see a huge impact is Portugal. And Portugal, it is a country that has a hot weather. So they are, in a way, concerned by, not all the countries, of course, but it is located in a Mediterranean region. In the Mediterranean region, there are several people that are concerned by hot weather. And also in France, you see, there is a good percentage of people. This is, again, about 10,000 people between 16 and 25 years old. So it is representing the category of the youth, of the youngsters. So you see that indeed there is the problem, there is interest, the problem is relevant, there are researches, etc. So let's look at more details. So de facto, how can climate impact us through local climate variations? And keep in mind that in the cities, the warming is larger. And if the global temperature increased like 1.3 in degrees Celsius from 1850, this is basically an accepted statistics, as we already discussed. in cities, and in some cities in particular, like Tokyo, Japan, the increase of temperature is more than 3 degrees. So basically, it's a huge increase due to the urban heat island effect, which we already mentioned, and due to air conditioning, due to lack of vegetation. Vegetation is a thermal regulator, lack of exchange of air, because in the cities there is the problem of less circulation of air. And I think Professor Capolongo may have already explained to you, or will explain to you, that indeed now they are developing kind of guidelines for the design of new quarters, a new portion of cities, and these guidelines tend to make sure that there are green areas. By the way, Milano Due has been a pioneering initiative on that, because there is a lot of green, and they also make sure that the air has flow channels, in order to make sure that there is a continuous exchange. But this is, of course, not applicable to all of the existing cities. And remember that in particular in Italy, most of the cities are protected because they are considered cultural heritage. So you cannot put a green roof in Bologna, in the center of the city, because it's not allowed, because of protection of cultural heritage, which is something that is quite relevant. So local climate is important. And then, of course, there are climate variables that are affected by change, which are directly affecting on the human body. And we will see later, there might be a direct effect and an indirect effect. So the direct effect is, for instance, the exposure to heat waves. The indirect effect is the vector-borne disease, which is a result of global warming, but it's not a direct effect. There is a vector in between. Okay, and of course, local conditions. I mean, the impact on Earth depends on the state of the country, on the state of the social system. We already discussed that, and on the state of the healthcare system, whether or not the healthcare system is prepared to cope with these changes, and also the water security state. Water is extremely important in order to cope with climate change, and under climate change, the quality of water decreases. Why? It's very clear, because warmer water means lower quality. The quality of the water is directly associated to its temperature. So when there is an increase of water temperature, it's a problem in the rivers, and we take water from the rivers, from the lakes, and I mean, higher temperature is problematic. And then there is less water. So if we take water from the river, you understand, when there is a lot of water, when the water is too much, it's a problem, because there is sediment transport and mobilization of contaminants. So during floods, usually we stop taking waters from the river, because we know that there is contamination by sediments, and we want to avoid it. We don't want sediments into the pipes, in the water supply systems. But on the other hand, when you have less water and there is a release of contaminants, a natural release at least of contaminants into the rivers, like animals, and if these contaminants are not diluted enough, it's a problem. So during droughts, usually we are much concerned. Also during floods, one of the main problems is indeed during floods and during droughts, make sure that water is not affected. And take into account that we consider it very normal that we open a tap and we get water from it of good quality. But actually, there are very important cities in the world where water is not drinkable. Like an example is Beijing. I have been in Beijing a month ago, and the first thing they told me is, okay, you can use it for brushing your teeth, but don't drink it, because it's not good water. And indeed, I don't go in China frequently, but I was very surprised that they used to drink hot water during lunch and dinner, but very hot water. So the first time I got like, okay, a kind of surprise. And the reason is that they boil the water before serving it. Sometimes even when they take water from the bottles, they got used in the past to boil the water before drinking it. So it's the fact that you open a tap and you always get water, even during droughts, and the water is always good quality. Take into account that it's a kind of a miracle that is the result of our evolution. It's very young innovation because, I mean, water supply systems in the form in which we know them now, they started after the Second World War. Okay, after, I mean, if you go back 100 years old, 100 years ago, sorry for that, in the houses, people, most of them, they didn't have in Italy the water from the tap. But on the other hand, the construction of these systems and all the treatments that are needed to make sure that water is always optimal quality made these systems very complicated, very complex. And making sure that even under extremes, they continue functioning is like making sure that during extremes, the healthcare system functions well. So water security is indeed a bit of a problem. And then local features of populations are very relevant in determining the climate impact on our health, like age, nutrition, and health state, general health state. And remember, when you try to assess what is the impact of climate change in the future on our health, you have to start from a very good assessment of the current state. So later on, I will start from this assessment of current state of health at the global level. And also, of course, climate change adaptation policies. So when you wonder in which way climate may affect our health, and when you want to develop a model to anticipate the effect of climate change on our health, you have to consider these issues. Okay, so local climate variation, the climate variables that are affected by change. Not everything is changing. Local conditions, local features of population, and climate change adaptation policies. We start from here. These are kind of input data. And then this is the first of a series of about 4 diagrams that were proposed by several international bodies working on health system, healthcare, and climate change in order to explain, disseminate in which way climate change may impact our health. When you assess this kind of information, you have always to take into account 2 things. First, uncertainty, okay, and I don't give any more discussion on it. Second, you have to take into account the controversial character of the topic. And therefore, any source of information must be analyzed, assessed critically. Because, of course, there are a lot of interests in promoting the agenda of climate change and then neglecting it. Like in any discussion related to human development, to planning of future activities, there are economic implications, there are implications, geopolitical implications. There are a lot of implications that, in particular with respect to climate, are very controversial. And therefore, you have to just take into account that they are controversial because your role is to get an unbiased view, okay, an unbiased assessment. So what are the variables, the climate variables? I mentioned earlier, climate variables that are most affecting our health. You see mentioned on the left here, precipitation. Temperature, heat means temperature, floods means river flow, and storms, which is, I mean, let me explain the difference in this diagram, as I understand it, between storms and precipitation. Precipitation is the whole body of rainfall plus hail, plus snow, plus fog. So precipitation is the transfer of water, the collection of the processes transferring water from the atmosphere to the earth, and precipitation includes everything. When we talk about storms, they should be more precise here. Usually we say rainstorms, snowstorms, windstorms, which is not related to precipitation. And so, as I see it here, I think that with storms, they are excluding what is related to precipitation. So maybe heat storming, or usually they are called heat waves, maybe wind storming, etc. So these variables, a change in these variables, end up with the health impacts that you see in on the right side. And here there is just a very brief list in this diagram. This diagram is from IPCC, so it's a reference that is scientific and climatic, is not a reference of, related to medicine, directly related to medicine, doesn't come from medicine. So the list, I think, is incomplete because they talk about undernutrition, drowning, heart disease, and malaria, but there are many more, okay, as we will see. The interesting thing is that they discuss the mediating factors, and the mediating factors are the environmental condition, according to their view, the social infrastructure, and the public health capability and adaptation. So you see that it's mentioned the geography. Why geography? Because geography is important. I mean, the morphology of the land surface is important in translating climate into the impact of climate. If you have a flat area, it's very different with respect to mountain areas, because the same precipitation generates a completely different response of the land. If you have steep slopes, for instance, or if you have a slope that is gentle, which means that you may have some infiltration of rainfall, for instance. So geography, baseline weather, baseline means the current weather, and soil dust, vegetation, etc., etc. And then they talk here about direct exposure, so flood damage, storm vulnerability, heat stress, and indirect exposures mediated through natural systems, allergens, disease vectors, increased water air pollution, and etc. And then the public health capability and adaptation, they talk about the warning system and the socioeconomic status and health and nutrition, primary health care. Let me spend a few words on the warning systems, because one of the solutions to cope with environmental extremes is through warning systems. They are called non-structural solutions. They are part of the category of the non-structural solutions. The warning system doesn't require a structure. It's not a structural change. It's a system that alerts people. And there has been a lot of progress recently. You may have, for instance, realized the progress in meteorology, in weather prediction. You may have realized the progress in warning systems like the red alert, the yellow alert. I mean, these have been the subject of intensive research and intensive technological transfer. They are indeed very important. Unfortunately, they don't work everywhere in the same way, and they are progressing. There is a lot of investments, but still, you know, sometimes we fail in providing alerts. For instance, now the Italian civil protection is working on the IT alert system. In Italian, it's called simply IT alert. And it's a system that sends SMS messages to the mobile phones that are located in the proximity of an emergency situation. Like you get on your mobile phone, it looks like you are in Milan, be careful because in 3 hours there will be a red alert in Milan. And this is, you may say this is redundant. What's new with respect to the alert, the classical alert of the civil protection? There is a big difference because the classical alert, you have to look at it. You don't receive it in your phone. And in this case, the alert comes to your phone and it's targeted. So it's not sent everywhere in Italy. It's sent only to the phones located into the cells which are exposed to the alert. And you may say, yeah, it's not so complicated. Actually, it turns out that it's extremely complicated because there is a risk of false alerts. And unfortunately, we know that false alerts are very damaging because they are undermining the trust of people in the system. So this is a first picture. I'll show you other pictures, and keep in mind that the picture serves to give you a conceptual basis. And it is trivial. I mean, all of what I'm saying up to now, it's very trivial. Like we have climate variables that are changing. There is a mediating effect of society, environment, healthcare system, and then there is an effect over humans, which is trivial. On the other hand, keep into account that our target, our final target is getting a model, is getting a prediction. So I have a prediction of climate change, fine. How can I predict the impact on the human health? I have to establish an analytical relationship between climate and health. And analytical relationship means that I have to quantify with numbers all of these things. Climatic variables is easy, temperature is a number. But if I talk about cardiovascular diseases, I need to associate a number. And a number which can be a statistic, which is what I want to model, but it's not trivial, the selection. So from a trivial concept, we have to set the basis for setting a model up. And of course, we are not setting up a model in 3 hours today, but we need to get the train of thoughts. We need to understand how it is set up. Okay, this is, as I said, one first picture. This is a second one. And it's a second one from, I don't remember, from, yeah, it's written here, and from World Health Organization. So it's a reference that is more related to medicine. And you see here, the diagram is very similar. Climate change, they mention melting of snow and ice. It was not mentioned earlier. And acidification of oceans, because more CO2 in the atmosphere means more CO2 in the oceans. And then they mention rise in sea level, which was not mentioned earlier in the previous diagram. Changes in the water cycle, this was mentioned previously, and increasing the intensity and frequency of extreme heat waves, droughts, floods, hurricanes. So they mention these, and they admit for some natural variability. This is a distinguishing feature of this graph, I think. And then they mention the human activities. And so they both regulate, have an influence on climate. There is a natural variability, of course. And there is, of course, a human activity. And we know that the big discussion is what is the incidence of human activities. The big discussion is whether mitigation policies reducing CO2 emissions will effectively mitigate or not climate change. We are not sure about that. But the fact that there is a natural component shouldn't lead you to dismiss climate change. Like, okay, it's natural, so that's fine. Nothing wrong with it, it's natural. Actually, it's not like that, because we have to be concerned also by natural variability. Variability of climate is a problem for our health and for our societal organization. It has always been a problem for humans, the variability of climate. In fact, usually, humans tended to establish in the regions where the variability of climate is reduced, is mitigated. They don't select the regions where climate is varying a lot. For instance, during the year, they went first in the regions where the temperature is more or less the same and there are no big changes. And so we don't have to dismiss it. And there is a second reason for not dismissing it. I mean, there is a human influence that is superimposed to natural variability. And we don't have to think that necessarily they compensate each other. There are some studies that demonstrate that the current global warming would have occurred anyway, even without humans. But in a more moderate intensity. And the superimposition of the natural variability and human activity is causing this warming that indeed is problematic for many reasons. We see every day that there are problems arising from this global warming. And then in this diagram, they highlight the individual vulnerabilities, which is okay. We already discussed it. Children and the elder person may be more vulnerable. The elder person, for sure. For children, it depends on the type of climate change that we consider. People with some morbidity already, with fragile health, and then there is a social and cultural context, political instability, and these are mediating factors. And these mediated factors, if we want to build the model, need to be numerically quantified. So you understand, it's not easy. We have to numerically, if we want to establish a relationship, a mathematical relationship, in order to get a prediction, we have to numerically quantify them, or at least classify them and attributing our own. We could use agent-based models, we could use other solutions, but we have any way to quantify the effect of these individual vulnerabilities. Usually we use numbers. And then there are the global environmental factor, pollution, global migration, and of course there is a baseline migration, which is still reinforced by the climate change and the changes in land use, urbanization. And you see that there is a direct pressure and an indirect pressure that is also recognized by the Health Organization. And they here, because they are related, they are close to medicine, they mention some of the illnesses, cardiovascular diseases, respiratory diseases. Let me just go through them. Gastrointestinal diseases, eye diseases, indeed, like conjunctivitis, it's sensitive to temperature, vector-borne and zoonotic diseases, skin disease, maternal and pediatric disorders, neurological disorders, kidney diseases related to hydration, and mental health disorders. When I pronounce the name of the illnesses, I may make you smiling, and please bear with me. I mean, I'm not a medical doctor, and in particular, I sometimes get wrong the pronunciation of illnesses also in Italian, because I don't know where to put the accents. But of course, when I speak in English, you have to bear with me, okay? I ensure to you that the pronunciation of the climatic terms should be okay, with some Emilian accent still, but some with a strong Emilian accent still. But you know, when I go abroad at conferences, they recognize in me the Italian region. You know, I think that they would recognize also some of the other regions, but still, there is to say that I recognize the French, I recognize the Spanish, the Greeks, but I can't locate the region so well. But the reason is that, you know, the Italian is, everybody knows it, so the Italian language. Okay, the example of the Lyme disease, it's what we also developed with the exercise. We estimated, we downloaded the data, you may remember last lecture, we downloaded the data of warming in Europe, and through quantification of the relationship between the temperature increase and the number of cases of Lyme diseases, we estimated the number of Lyme diseases. And be careful, quantification of the relationship between temperature increases and number of cases. This is the modeling part. This is the analytical part. I did it very simply by saying, I don't remember, like 10% more for each degree of temperature. It's a very simple model, but it needs to be modeled. If we want, again, to make predictions, if we want to get prepared, if you want to warn people, we need predictions. It's not just an intuition that we can say like, okay, we predict it will be warmer, so be careful of the Lyme disease. But people need a more rigorous estimation. When we talk about a model, keep in mind that a model can be very simple. Not necessarily a model is complex. In some of the cases, it's even better if it is simple, because if a model can be understood, by your patients, it's much better, because again, keep in mind that you need to preserve the trust of people in yourself, first of all, not only for your individual career. Of course, for your individual career, trust of people is a measure of success. When you will become a medical doctor, if very soon, if people trust you, this is a measure of your personal success. But it's not only personal. It's the whole healthcare system that gains if you gain the trust of people. Remember this, because I see many professionals, sometimes they don't care about it. They just say, this is what I predict. And that's true. You don't have to question it. This is detrimental for the individual career. And I like to start the point of the individual career, because what I tell to these people is, look, how can you have success in your career if you communicate in this way? Like climate scientists, sometimes they say, I know it, and I got replies, sometimes you are an hydrologist, not a climate scientist, so please don't question. And my reply in this situation is simply, how do you get the trust of people if you behave in such a way? And it's, first of all, a problem for you, for your personal success. And then it's a problem of the collective society. But on the other hand, sometimes when I communicate, I understand that when you talk about people, about the common good, people say, okay, who cares about the common good? Others are caring of it. And it's not my individual contribution. So I prefer, when I want to deliver a message, first I like the personal benefit. Okay. I mean, we are discussing, I want to keep you just awake and aware of our steps. We are discussing climate impacts over Earth, and we are setting the basis. We are trying to set the basis for a model. Okay. Okay, so let's start from the baseline. As I said, if we want to understand, if we want to set up a model, if we want to understand how the future will be, if we want to make future predictions, we have to start from a baseline. And the baseline is the state of the global health. And you are better than me in understanding this. I just want to highlight one important thing. The state of the global health is improving, of course, with differences in the countries, but life expectation, just to give you a message that people will understand, is getting longer and longer. And in the future, it will improve again. Of course, with different pace. We will never get to people 1,000 years old, but probably in 30 years from now, the number of people above 100 will be much larger. This brings other problems, but the message is the global health is improving. And then climate change is expected to have a damage over the global health. This, like our development in general is expected to have some negative impacts. But we should always look at the balance when we make predictions. So if we neglect the progress of the healthcare system of our global health in the future, and we only focus on the pessimistic message, like we will have more diseases, more cholera, more Lyme diseases, more and more of everything, more people die for heat waves. I mean, this is not a useful way of communicating, because these pessimistic views generate anxiety, generate undue concerns. It's a different story if we start by saying, look, our development is ensuring an improvement of the state of the global health. Of course, any development has implications, and there are some negative implications of the developments. We will see that even climate change adaptation has some negative implications. But these negative implications, maybe they are overcompensated by the benefits. It depends on the country, of some local situation, which we already started to discuss. So what is the moral of the story? The moral of the story is that we have to identify through a model the conditions where the benefit may be indeed completely offset by unfavorable conditions. And in these hotspots, in this delicate situation, we have to intervene. And we have to concentrate our effort precisely where we think that there is a real reason of concern. And this is a message that is more effective. Okay, so let's talk about life expectation. Our world in data gives this nice graph. Let me see the timing. Okay, I am still in time. This is a very, as I said, naive graph of life expectancy in historical levels, historical, current, and UN projections. When we talk about projections, it's I mean, the lower graph refers to a time period that is clearly indicated. The upper graph is not the same time period. This slide may be a little bit misleading. It's not, with historical, and you see the life expectancy was 45 years. Historical, we mean like middle age, okay, or even earlier than that. I'm not really sure. We should look at my web pages where there is the source of this graph, and there is a clear indication of what they mean, what is meant here with historical. But looking at the life expectation, you know that in the prehistorian age, the life expectation for humans was about 25, 30. And then I see 45 here, I think maybe related to the Roman age, more or less. And the current is around, this is a graph that was extrapolated 2 years ago, and it was reporting 75. Now it's already 79 for the men and 83 for the women. And in the future, it will increase again. And what you see in the lower graph is the percentage of change, which is oscillating because, you know, in this data, there are some sections of the graphs that are very steep. When we estimate the life expectation, there are uncertainties also in these estimates, and sometimes there are these steps, these abrupt changes, which are probably due to uncertainty in data retrieval. What is important to notice in this graph is that, of course, the improvement in life expectation is going down for obvious reasons. I mean, it's like when you try to warm an house, when it is very cold, you gain temperature very rapidly. When you get to a warm temperature, you have to put a lot of energy if you want to warm it up again. And this is the same for life expectation. We are improving, but there is an asymptotical limit, which is probably not, I mean, I would say that it doesn't exist an upper limit to the human age, but there is an asymptotical tendency to that. And therefore, I wouldn't say there is an upper limit. This is more a philosophical than an applied question. Like we say, there is not an upper limit to river flow or to rainfall. Some of my colleagues say, no, there is indeed an upper limit. But anyway, the message is clear. The improvement has been more remarkable in the past. It will be less remarkable in the future. But still, from 2000 to 2025, there has been a huge improvement in life expectation. And I remember in 2000, it was 73. And now it's 73, it was for men. Now it's 79. I mean, 6 years in 25 years is a huge improvement. So this is something that has to be conveyed, and despite the climate change that occurred. So it means that for the future, and here there is the graph for Italy, for the future, which is more or less the same, okay, for the future, we can be, I mean, we should start from an optimistic premise. And this need of establishing a baseline, this need of, in a way, understanding this trade-off from development, which has positive implication, but has also negative implications, and the impact of climate change. a similar discussion could refer to the resources. We will be more and more efficient in exploiting resources like energy, producing energy. In the future, nuclear fusion will become a reality, and maybe even earlier than we expect. Now we expect that by 2050, we still will be not ready for nuclear fusion. Nuclear fusion is production of energy from nuclear processes, which are not dangerous, are not generating radiations, are more efficient, are less expensive. When nuclear fusion will become a reality, we will have a lot of more energy, and hopefully everywhere. The same for water desalination. When water desalination will become affordable in terms of energy requirement, in terms of cost, we will be much more effective in getting water and therefore ensuring societal development. So let's be careful about assessment of the current situation of the current state of the global health, and let's now look at instead of the view by IPCC. IPCC is more pessimistic, of course, because the mission of IPCC is to warn people against the risk induced by climate change, and therefore they are quite pessimistic. So they say already 10 years ago in the fifth assessment report, people affirmed with high confidence, just keep in mind this connotation, high confidence, that human health is affected by climate change. And you may say, yeah, of course, it's trivial. You are teaching us already 4 lectures on that, but it was 10 years ago. So 10 years ago, 20 years ago, the global health was not really a concern in relation to climate change. And they predicted a lot of problems, from injury, disease, and death due to intense heat waves and fires. Very high confidence. Just keep this connotation in mind. And undernutrition, food and waste-borne diseases, very high confidence. Waterborne diseases, medium confidence. Okay, so you see the importance of establishing a baseline. Why did I suggest you to keep this connotation in mind, very high confidence? Because the IPCC quantifies the reliability of predictions, quantifies uncertainty by using this terminology. And so they say that the confidence is ranging from very low to very high. And they say, I predict that there will be more waterborne diseases, vector-borne diseases in the future with medium confidence. So what is the origin? What is the generation? How these connotations are generated? Okay, and you see the diagram on the left. So the confidence is ranging from white, lower left, to dark gray, upper right. And it is estimated based on two kinds of information. The first is evidence. Evidence means data. And the second is agreement, is consensus. This is a bit criticized by some scientists because consensus shouldn't be the way to judge the reliability of science. Shouldn't be consensus. Consensus in the past, unfortunately, created disasters. And you may look at the history of Galileo, but more recently to the debate on eugenics during the Nazi domination. And there was a lot of consensus on eugenics that led to the establishment of the racial laws. There was a lot of consensus. So consensus, I don't think, should be really used to judge, to assess, again, the reliability of a prediction. They use also data. And basically, they say that when there is a high agreement and a robust evidence, they say very high confidence. When there is a low agreement and limited evidence, then there is, they say, very low confidence. Just to give you this information, if you read predictions by IPCC, which is anyway a very important information, but it should be taken into account by considering that is also generated by agreement, not only fact. Of course, they have a justification on that, because we have only a limited amount of climatic data. So evidence-based is something that is, in some of the cases, cannot be used. So I heard a distinguished colleague once telling me, we cannot close the Gibraltar Strait and to see what happens if, with lowering sea level, the Mediterranean gets disconnected from the Atlantic. We cannot now make an experiment. So we have to reason, we have to get consensus. We have to rely on consensus. So there is a reason for that. On the other hand, can you imagine if in deciding a therapy, okay, of course you consider consensus, but you also consider a lot of statistics. And before trying a therapy on humans, you know better than me what is the process of testing, which is based on evidence rather than consensus. And then, of course, you may, in some of the cases, you may need to rely on consensus, but I mean, it should be just taken into account. Okay, another graph, climate impact, environment. I'm skipping this, okay, because this is a third one that I found. This is, I think it's the UK Earth Agency. And again, they say, look, there are climatic variables affecting our health, mediated by the institutional context, mediated by the societal context, and then the health outcomes are listed here. But as I said, I skip this because it's already established. Now, let's make a step forward through a mathematical model, a step forward to a mathematical model, sorry. When I speak for a long time, you know, the quality of the English goes down. So, and you have to be patient with me. So, by the way, I didn't speak any English. Okay, I attended English during my secondary school and high school English courses, but it was like 2 hours per week. At the age of 28, I was still unable to survive in an English-speaking country. So you have to, in a way, bear with me. And after that, I tried to practice a lot. But now I'm thinking of applying for chair in Germany, and I really would like to finish my career abroad. Like I really would like to make an experience of teaching abroad, but a continuous experience. And you know, I read the call for application, and they said, okay, in the master degree you are allowed to teach in English, but in the bachelor you have to teach in German. And German, I don't know anything. And they say, okay, if you don't know German, it's enough a commitment by you that in 6 months you will become able to teach in German. I'm not sure. I will apply, but I'm not sure in 6 months I can learn German. Teaching is easier than surviving in a daily environment, of course, but still. Anyway, let's go back to our step forward to an analytical description. And we may use the WHO guidance on research methods for health emergency and disaster risk management. Is very recent, and they borrow the concept from the general scientific approach for environmental risk estimation. So there is indeed a guidance about environmental risk estimation, which was proposed about 30 years ago by international bodies. And The international body is UNISDR, which I don't remember. I know the acronym, but it's United Nations. I don't remember. We should look over Google. But there is this intergovernmental body of the United Nations that proposed this procedure for environmental risk estimation with the purpose precisely of giving a quantitative estimation of the risk. And in this case, it is borrowed by WHO for estimating the health risk numerically. So here, it's not written down the relationship, but let me explain in words. Risk is indicated with R. And we talk about risk associated to an event. So it could be a flood, could be, the event could be an outbreak of an illness, like the outbreak of a pandemic. Okay? And the risk is indicated with R and is given by the product of three factors. And it is described here in words, but I realize that probably on the website, in my web tutorials, there is the relationship, it's not here. Anyway, three factors. Factors means that there is a multiplication. So the first factor is probability. Probability of occurrence of the event, of the pandemic outbreak. So probability. That is multiplied by vulnerability. I'll define what vulnerability is. Vulnerability of the societal context that we are referring to, which is multiplied by the third factor, which is exposure. So three factors: probability, vulnerability, and exposure, and they are mentioned here. I multiply them and I get an estimate of the risk. So let's try to better discuss what I just said. So what is the probability, which is also called hazard? I think you have a very good background in probability. So I'm not discussing probability. I just remind you that probability is associated with a frequency. Like, what is the probability that next year we will get a new pandemic? And the probability, you can estimate it with an estimate of the frequency. So you look at the past history and you look at the number of pandemics in the last 100 years. So if it is 3, for instance, and of course you have to define a geographical context, you have to define what is the context you are referring to. But let's suppose that it's 3 in 100 years. It means that you have a frequency of 3 divided by 100. And this is the probability of getting a pandemic in a given year, under certain assumption that here we don't discuss. So probability can be estimated with the frequency. Don't forget, as I said, I'm not saying anything more about probability. I know that probability is a tedious concept for students. I was the first one to really hate probability when, during my university studies, they tried to teach it to me. So I perfectly know, and I agree with you, that it's very boring, very mathematical, very tough. But probability for your professional career, a good understanding of probability is essential. And just keep in mind, if you want to get stimulated, that probability is just trying to search for regularities in events. You have events, and you try to understand, through observing these events, you try to understand patterns. It's just that. And it is something that we are very used to in our everyday life. We know what is the probability if I open the fridge tonight to find a full bottle of beer. I know that it's very unlikely because my son probably already drank it. So it is just looking for patterns in events. This is probability. And then, of course, in order to be very reliable, because probability is rigorous, is extremely reliable. If it gives to you the means to check the prediction, then it becomes complicated. But in principle, it's very simple, okay? And don't forget that we can talk about, when we talk about events, usually what we do to estimate probabilities is to translate the event into a number. So we got an earthquake. What is the first thing that people do with an earthquake? Estimate the intensity, report the intensity. This means associating a number to an event. Okay? This is usually what we do. And then we describe the probability of numbers. When we, some probabilistic descriptions, probabilistic methods like describing events with the Gaussian distribution or normal distribution, you know it. I know that you know because I asked your predecessors in the past years, and they said, yes, Professor, don't speak about probability because we had already too many hours of teaching about it. And just remember that it refers to numbers, and just ask yourself if you are confident, if you are well acquainted with the difference between cumulative probability, probability density. If this terminology looks a bit strange to you, my advice is try to fill this gap, because probability for you is extremely important. Like I say the same thing to engineers. You cannot be an engineer if you really don't have a good knowledge, not perfect, a good knowledge of probability. And you can test your knowledge with the terminology. Just look for probability over Google, open a web page, and look at the terminology. If you understand what they are talking about, you understand what is probability density, what is the difference with cumulative probability, you understand what is Gaussian distribution, normal distribution, that's fine. You don't need to know the theorems or whatever. Okay, so first of all, we have to define the probability of something happening, and then we estimate the impact on the humans through the other two factors. What I'm saying is trivial. If the probability of something happening is 0, there is no impact over the humans. Trivial, okay? So this is a product, 3 factors. So if probability is 0, there is no risk for the humans. And you understand that if the probability is very low, the risk for the human is very low as well. If the probability is large, then it becomes a problem. So why did I mention the hospital of Pesaro? Because there are doubts on the probability that the hospital is flooded. Of course, if we talk of an hospital cannot be flooded. We have to be dead sure that it's not flooded. And if we have doubts on the probability, it's a problem. What is vulnerability? Vulnerability is the probability, again, that the system gets damaged if the event occurs. So let's start from the fact that the event is occurring, is a fact. So the probability is taken aside. The event is certain, occurs. So what is, again, a number varying between 0 and 1 to quantify the likelihood of the system being damaged? So I could say the hospital is exposed to flooding, but vulnerability is 0. This means that even if the hospital is flooded, water doesn't get into the hospital. So vulnerability is a measure between 0 and 1, and for this reason we call it a probability. A measure between 0 and 1, quantifying how likely is that the system gets damaged. And then we have the exposure. The exposure is the value of the asset, not necessarily expressed in monetary terms. Before I talk of exposure, let me just say for vulnerability. If vulnerability is 0, no problem. The risk is 0. Okay? Exposure, the value of the asset, not necessarily in monetary terms. But let me refer to monetary terms because it's easier to be understood. So let's suppose that the event occurs. Let's suppose that the system is vulnerable, but the value of the system is 0. So there is no risk. So let's suppose that the system is a desert area, is vulnerable. If a flood comes, the desert area is flooded because there is no protection. If the flood comes, however, vulnerability is 1, but the value is 0. I have no damage, so no risk. And you could quantify the damage also for the hospital, the exposure for the hospital, like, let's suppose that a flood comes and the hospital is vulnerable, but what is flooded? It is flooded only a part of the hospital that is not necessary to manage the emergency. So you could say the exposure is very limited. And on the other hand, it is flooded in a theater. No, it's not. The exposure is very high. Okay, or it is flooded the power generator, the backup power generator. Then exposure is very high. So you have to estimate these 3 terms, and you multiply them with the product, and you get an estimate of the risk. Now let's look at units here. Probability is dimensionless. Vulnerability, look at how it is defined, is dimensionless. Exposure, it's an estimate of damage. So a possibility is that you estimate it in terms of human lives that are lost or economic damage. The result is that the risk has a unit, which is the same unit as exposure. So let me now, and then I make the break, make this example. Let's suppose that I deal with a flood, and forgive me if I continue to make examples with the floods. It's, how to say, it's, I don't know how to say in English, deformazione professionale. And anyway, let me make an example of the flood. We can estimate with different techniques, various techniques, the probability that my university gets flooded next year during 2026. Okay, I can estimate the vulnerability, and I can estimate the value of the asset, the economic value of the asset. And then let's suppose that probability is 0.1. Actually, is much lower, but let me make a simpler example that I can make by words. Okay, let's suppose that probability is 0.1. Let's suppose that vulnerability is 1. And let's suppose that the asset has a value of 100,000 euros damage. So the multiplication is 10,000 euros. This means that my expected damage for the next year in my university for flooding is 10,000. So this is a way to make a prediction of the expected, again, damage, which is 10,000 euros for my university next year. This allows the university to make a budget. Like, I know the risk to which I am exposed. In my budget, I put 10,000 euros to cover the risk. And this is what insurance companies usually do. When you open a contract for your car, they know the probability based on your age, based on your past history of car accidents. They know the probability that you will cause them an accident for the next year. They estimate their exposure, the value, based on their techniques, and then they determine what you have to pay to cover the risk. And usually they stay from the safe side, because indeed you may think, okay, I pay like 300 euros to get the insurance of my car, and but it's worth spending because I mean I can get a damage that is much larger than that. But usually the average person, if you make the sum of what they pay during their life for insurance and what they get from the insurance to cover the damage, they pay much more than that. Of course, we are willing to pay because we don't want to take the very large risk of causing a big accident. But the insurance companies, they know statistically what is the probability, what is the exposure and the vulnerability. They make this computation. And if they really don't know how to estimate vulnerability, they can reach a professional like what is the probability of flooding under climate change. They typically go to a climate scientist and say, can you please tell me in the future what is the expected flood probability? Because here the key step, as you already have understood, is how to estimate probability, vulnerability, and exposure. This is the key step now. This is what we miss for our model. If you want to estimate the risk that an hospital is flooded, of course, you have to estimate the flood risk. And I tell you, this is the simplest, the flood probability. This is the simplest part. Probability, usually, it's not so problematic to estimate. But vulnerability is a big problem. And exposure, it's a big problem. Okay, let's make a 10 minutes break. You don't have any questions, so I don't ask you anymore. Okay, thanks. Sì. No, stavo solo cercando di chiudere il microfono. Aspetti, sa che provo un attimo a vedere, perché altrimenti facciamo una cosa. Aspetti che ci... Sì, però non credo che... Era rosso. Ho il timore di non aver registrato. Vabbè, lo stesso mi dica. Sì? Però non l'ha registrato? No. Ma io posso avviare?
Sì, funziona qui. Carica, però che domani mi devo mandare una richiesta che mi deve approvare.
Ah, ok, perfetto. Sì, no, questo ritorna.
Ok, le lascio io.
Sì.
Yes.
No, perché comunque lei mi manda la mail, no? Quindi va benissimo.
Mando anche una mail. No, di solito non c'è la...
No, una mail comunque. Ok, lei come si chiama?
Spesa, Pecorari.
Ok, va bene, perfetto.
Ok, va bene,
Perfetto. Sì, no, non preoccupatevi, tanto le finirò alle 6:10, non è un problema. Va bene. I am pretty sure that I forgot to turn on the mic. So I will make the video available anyway. If you don't see the audio for the first part of the lecture, I apologize. And I hope that you can get the essence anyway from the slides. Okay, so I thought that I didn't have the relationship in clear, while indeed it is here. So this is the relationship that we discussed. The risk is expressed as the product of PVE. P is probability, also called hazard. B is vulnerability, and D is exposure, as we said. Now, so the problem now is to estimate these three individual components, three individual factors. I'm not going into the details, in particular for probability. So most of the next slides, I will basically skip with a few comments only. And first of all, probability, we already discussed it, and you already know about it. So here there is also in the web pages, in my tutorial, I have put a box with the definition of probability. It's just enough that we take the definition that I provided to you. Probability is a synonym of frequency, okay? Once again, just keep in mind that when we pass from an event to a probabilistic description, you need a number. And this number, if it is discrete, so this variable describing the event, if it is discrete, it's defining probability is relatively simple. Like if you take an earthquake, the intensity of the earthquake, if you round it to the integer, like intensity in the Richter scale, 1, 2, 3, 4, 5, 6, it's easy to determine the frequency and then the probability of an earthquake of magnitude 6, because you count the outcomes. And of course, you also count the outcomes of the earthquakes that are lower than 6, and you get the probability. It's very easy. If the variable is continuous, so the intensity of the earthquake is measured not only with the integer, but you take a real number, real means infinite digits, then probability becomes more complicated. And you need to refer to probability density in order to manage it. And this is why I mentioned to you, try to make sure that you know these terminologies and you know what is the conceptual problem in estimating probabilities. Okay, so probability, there is here another example related to tossing two dice. And what is the probability of a given outcome? The outcome is the sum of the two numbers coming from the two dice, and this is relatively easy, and not relatively easy. I skip it, and so now let's discuss a little bit this slide. If we are talking about climatic events, how can we estimate the probability? If we refer to the past, we usually refer to observation. This is the classic approach in environmental sciences. When we want to estimate the probability of extremes, we look at observations and then we get it under the assumption that the past is representative of the future, because usually when we estimate probability is for elaborating a future prediction. And therefore, we assume that our observations are representative of the future. And there is an historical literature on that. Probabilistic analysis, people started centuries ago, and there is a literature that is very extended, very also tested, because also this is very important, that the theory is tested. But when we refer to the future, how can we solve it? Of course, through climatic projections. And then you have also to account for uncertainty. Okay, so climate projections, indeed, all the models that we discussed, all the data download procedures, these refer to estimating the probability, the future probability of climatic events. And then we don't discuss about probability anymore, okay? And probably you, as a medical doctor, will refer to a specialist for downloading the data or making a future assessment, but it's also very important that you have the basic knowledge of how this is carried out. Vulnerability requires an analysis of the social context, and in particular of prevention policies, state of the healthcare system, state of the hospital, etc. This is something that is potentially very complicated. Exposure estimation is based on an economic or social analysis of the monetary or physical damage that may occur to the population if an hazard materializes. And so you see that it's a kind of socioeconomic analysis is needed for both vulnerability and exposure. In the classic approach, the climate component is related only to probability, and then vulnerability and exposures are based on socioeconomic analysis, socioeconomic predictions. Remember that when you study the literature, you may find slightly different definitions of vulnerability, exposure, and probability. So you may see, for instance, in some of the literature that climate change adaptation reduces the probability of an event. I don't agree with this interpretation, but it doesn't mean that it's incorrect. I prefer an easier interpretation and say that when we work with adaptation, we reduce the vulnerability or we reduce the exposure. Adaptation doesn't mean that we reduce the probability that something will happen. It's maybe climate change mitigation that is reducing the probability, but for adaptation, we need to work on vulnerability and exposure. I think this is clearer. Climate is related to probability, and therefore climate change mitigation means that we change the climate, we change the probability. The socioeconomic context, the healthcare system, our preparation, the early warning systems, they refer to vulnerability and exposure. Adaptation refers to vulnerability and exposure. So for what we are concerned of, the health system, how can we estimate vulnerability and exposure? So first of all, here there is a discussion, some slides related also to the discussion of probability, which I will quickly pass. What I want to introduce, and basically I want to close this lecture and also my lectures with considerations on this issue. I want to emphasize that in the context of healthcare, assessment of vulnerability and exposure is usually done through health determinants. I think probably you were already introduced the concept of health determinant. What is an health determinant? In our case, the health determinant is something connecting changing climate with the state, the risk for the health. So it is, we need, if we want to identify an health determinant, to determine numerically what are the drivers of the illness, of the considered illness. So for instance, an health determinant may be air quality. Air quality is a determinant of illnesses like respiratory diseases. And therefore, we quantify air quality with a number, and we connect the change in climate with the change in air quality to get an overall connection between the change in climate and the change in health through the health determinants, which is air quality in this case. It can be water quality, an health determinant. It can be the GDP, gross domestic product, of a country, an health determinant, because if the country is rich, of course, they have resources to get protected. Good. Now, let's then start the discussion of this health determinant. And I'm skipping the hazard change due to climate change because we already discussed it. How to download the data, the climatic projections, and how to identify the variables, temperature affecting, which is a climatic variable affecting health. We already discussed them. So let me skip it. And also, let's skip here. There are some more details on what can be the most important climatic variables. We are not interested. This is already too much technical for our purposes. And then here there is how to download the data. We already discussed it. The climate scenarios, the emission scenarios, sorry, which are based on socioeconomic predictions of CO2 emission in the future, which determine the output from the climate model. We already discussed them. So let's forget it. And also historical analysis. And then let's go here to a first discussion of climate determinant, the climate determinants. And in order to introduce it, I want to start from and a contribution that I believe is very interesting, which evaluated the effect on the health of policies for climate change mitigation and adaptation. And they needed to make this estimation, again, of the effect in terms of health of climate change mitigation and adaptation. In order to make this estimation of this effect, they passed through health determinants. And it is, I think, an interesting study, which is a review study. What they did is to browse the literature and make a statistical assessment of the papers that evaluated the outcome from climate change mitigation and adaptation policies. So they made this review and summarized what the papers said. And therefore, through this review, which refers to a very specific case, we have a list of health determinants that were considered in these papers. I said this review refers to a very specific case. It is the effect of climate change mitigation and adaptation. But it is a useful review, very recent one, and let me see. Yeah, it's basically after 2020. I think it was published in 2023, but I'm not really sure. It is the reference is in my webpage. And basically, with this review, which refers to this very specific case, we can get a first list of health determinants. And then I will give you other information, other examples before the end of the lecture in the next 30 minutes. Now, let's try to summarize this contribution by first taking into account that when you realize, develop an intervention, when you set a measure for mitigating climate change or adapting to climate change, you have positive outcomes, hopefully, but you also have negative outcomes. Let's make the example very significant, in my opinion, of air conditioning. Air conditioning, of course, has beneficial effects because it protects people against heat waves. But air conditioning can cause, as we know, respiratory problems. and can cause health problem for the big jump in temperature when you get outside and inside, outside and inside. So, I mean, when we adapt, there are also unintended consequences, and therefore they didn't make a difference on that. So when they analyzed the effect on the health of climate change mitigation and adaptation, they didn't focus only on positive effects. They also focused on negative effects. So when I present these results, just keep in mind that the implication may be positive or negative. Next one is just a statistic on the number of papers that they dealt with. And the total number of papers was like 56 for climate change adaptation and 83 for climate change mitigation, or the other way around. Anyway, in the two categories, you have a total of like 130 papers. The numbers are reported precisely in my tutorials. And you see here that there is a statistics of the number of papers that they detected, divided, split into adaptation related and mitigation related. And there is the list of the issues, of the medical issues these papers referred to. So for instance, look at accident injuries, so traumatic impact, and they found only like 3 mitigation related papers. And if you look at food and nutrition related issues, they found 1 paper related to adaptation and 3 papers related to mitigation. The largest number was referred to non-communicable diseases. Look in the list, there are other non-communicable diseases, like mental health is non-communicable. And my understanding is that, based also on the reading of the paper, is that they put in the category non-communicable all the diseases that they couldn't classify in the other categories in the list. So if you look at non-communicable diseases, they found a lot of papers related to mitigation, and so about 29, sorry, and 5 papers related to adaptation. So the category with less paper is adaptation. And you don't have to be surprised, because in climate science, adaptation is not popular. In climate science, they want to reach the target of mitigation. And therefore, you will find adaptation papers in the engineering literature, but not adaptation papers in the climate science literature. These non-communicable diseases, they also split them in respiratory tract related, diabetes, dementia, and cardiovascular diseases. CVD is cardiovascular diseases, and cancer. And you see the number of papers. And there is also a huge category unspecified. This is just, it's not related, not yet to health indicators, health determinants. It's just a statistics on the number of papers that they found. By the way, this kind of bibliographic assessment, bibliographic review is becoming very popular, because with the advent of the modern and open system for literature classification, literature browsing, and in particular with Google Scholar, it became very easy to make these searches for papers. And now with artificial intelligence, it's becoming much more easier. And it is interesting, the fact that you have to take into account that Google Scholar, I think it became available like 15 years ago, no more than 20 anyway. And before than that, it was not possible to openly browse the scientific and humanities literature. Artificial intelligence now makes it even more open, because artificial intelligence doesn't only look at peer-reviewed papers, it looks over the whole web, like Google, but artificial intelligence also looks into blogs, into sources of information that are not browsed by Google Scholar by default. And therefore, artificial intelligence is opening new doors also in terms of looking at the literature without any filter. Because if we only look at scientific papers, it's a filter, which, I mean, has a reason to be, but it's still a filter. If we look at only the peer-reviewed literature, is a strong filter, which is excluding what is not peer-reviewed, the so-called gray literature. Now, what is the implication of this, of making it more open? The implication is that the amount of information exploded in the past 2 years. The amount of information that you get from the web related, for instance, to health determinants or climate change impact on the human health in general, it's exploded. But on the other hand, it requires, given that there are no filters, that you are the filter. And therefore, this implies an increase of responsibility. It's easier for you to get the information. And it's fascinating because it's removing filters done by others, but then is giving to you a huge responsibility in terms of filtering the information. And you know, when you look at the whole web, the rubbish is really large. It's really large. So you have to, again, I pass another time this message. Artificial intelligence is great, but it's not intelligence. It's you, the intelligence. The artificial intelligence is a lot of information that you have to select and filter with your intelligence. Okay, now let's look at some results. And so first of all, a summary. Regarding Earth impacts, 65 articles found only positive impacts, and only 5 articles only negative impacts. And 14 articles found both positive and negative health impacts related to climate change mitigation and adaptation, interventions for climate change mitigation and adaptation. We will see what these interventions are in detail. And regarding the nature of the reported health impacts, around half of articles reported only mortality-related health impacts. So, like, for instance, avoided or excess premature death. Over a fifth of the articles, 21%, reported only morbidity-related impacts, which were quantified using different techniques, different indicators, different health determinants. Morbidity like disability or disease cases with incomplete recovery, number of hospitalizations, etc. And the remaining article, 30%, reported both mortality and morbidity. Now, what is this diagram? This is called a Sankar diagram. It is a diagram that is about 200 years old. And it's a graphical representation of results. And it's a diagram that in general can be used to describe flows of whatever, information, energy, or impact flow through different states or through different times. Okay. In this case, what does show you? It starts from the left, from the system. So this is first, this is related to climate change adaptation. So this system is like critical infrastructure. So it is adapting to climate change critical infrastructures or network and services. Okay, remember we are talking about adaptation intervention. So the system identifies the system that is affected, impacted by adaptation. So critical infrastructure, the upper one, human health is just below, and then other cross-cutting risks, living standards and equity, water security, and food security. Okay, the system. Second column, measure categories. And this is already interesting because it gives to you a list of the interventions like air conditioning, green infrastructure, and then ecosystem services. You will study ecosystem services are much relevant to mitigate the impact of climate change. It is adaptation realized with natural solutions and through the use of ecosystems like water sanitation through the use of biodegradation. Albedo increase, including cooling roofs. Albedo increase means that you, for instance, or albedo change, green roof change the albedo. What is the albedo? It's the quantity, is what determines the reflection back to the atmosphere of solar radiation. So if you have a high albedo, it means that the solar radiation is not given back to the atmosphere, but is trapped by the soil. And therefore, it is better for us because it mitigates temperature. Okay? So sustainable land use and urban planning, it's an intervention for adaptation. I mentioned earlier the flow of air through cities. And then health care system adaptation, climate services. Climate services means providing climatic information to support adaptation, like early warning system is a climate services, a service, it's singular. And then there is social safety, and then there is disaster risk management, livelihood diversification, water use, etc. The connection between the first column, the system, and the second is through arrows, or let's say, you don't see the arrow here, but it's through a connection whose width is proportional to the intensity of the flow. The larger the connection, the larger the flow. Okay, the larger the importance of the connection between the system and the measure category. And then there are a first example of health determinants: air quality, air temperature, capacity of healthcare system is an health determinant, has an effect on our capability to prevent diseases, and access to health services, employment income is an health determinant. I mentioned the GDP, the gross domestic product of the country, and it was not just by chance. And employment income, yeah, already mentioned, access to food or diets, and access to education, it's an health determinant. And I would also include here public trust is an health determinant for sure. Okay, and housing conditions, water quality, water quantity, access to drinking water, and access to sanitation facilities, and access to food. I mean, I want to emphasize here the width associated of the bar associated to the health determinant is not related to the importance of the health determinant, is related to the relationship between the intervention and the health determinant. Okay? Because I mean, water quantity or access to drinking water is a very important health determinant. Don't just get confused because you see that here it's small. I want to thank you very much for attending my lectures, and once again, just thank you. And I'm giving a thank you collective at the end of the lecture, but you're leaving, okay? And no problem, bye-bye. And then you have the diseases, the health outcomes on the right. And you see that there is non-communicable diseases, and in particular here, cardiovascular diseases, 6%. The 6% means that these papers, these measures were related to 6%, for a percentage of 6% with the cardiovascular diseases. So when you see 6% here, it means that these measures, these interventions were related, 6% of them, to cardiovascular diseases. Non-communicable diseases, another category, it's respiratory disease, 6%, unspecified disease, 67, and then MNCH is, let me just check. Mental health, 2%, soil, water, waste related diseases, vector related diseases, and food nutrition diseases. MNCH, I need to go to the, here, MNCH. Okay, maternal, neonatal, and child health, MNCH. Sorry, I didn't remember. This is the diagram for mitigation and adaptation. So let's look at those determinants. Again, air quality, air temperature, radiation. I mean, I looked over the paper, and there is no definition in the paper for what is meant by radiation. I think it is radiation from nuclear emissions, not solar radiation, because I understand that because here radiation is connected to nuclear energy production. Because the measured categories you see are completely different with respect to the previous graph, completely different because these are mitigation categories, and so they are much related to energy production, and there is nuclear energy, and nuclear energy is connected with radiation. And also solar energy is connected to radiation because solar energy is reducing radiation and nuclear energy is increasing it. So I think this is my interpretation of what they mean for radiation, but through the paper, there is no mention of it. And this is a limitation for a scientific paper, of course. And but you know, scientific papers by definition are never perfect. They propose innovation and they are peer reviewed, but sometimes you have to integrate the reading with your interpretation. And then there are the outcomes that more or less are the same as before. So this is a first list of health determinants. What can we say more? And first of all, health determinants are defined, sorry if I give the definition only now, defined as features of biological, sociocultural, economic, behavioral, and institutional systems which may affect human health. So sometimes they are also called health indicators. I prefer determinants because indicator is a passive association, a passive connotation. Determinant is an active connotation, so I prefer determinants, okay? But sometimes they are called indicators. And so what I think is a very interesting reference for the identification of health determinants is, I found very useful the initiative Lancet by Lancet called, Lancet is a scientific journal. I think you know it because it is essentially related to, I mean, several different sciences, but with a particular focus on medicine and health. So the initiative is called the Lancet Countdown, Tracking Progress on Health and Climate Change. And so basically, the Lancet Countdown issues every year a report since 2015. And this report is the result of a global monitoring system that tracks, I'm reading, the complex, reflective ways in which climate change affects health. And the Lancet Countdown is considered a set of climate change and health indicators. So these are indicators, health determinants, which are specifically related to climate change. And you see, they use here health indicators. I'm not really sure whether it was wanted, this reference to a passive connotation rather than an active connotation. I would prefer they have used determinants, but anyway, we understood what we mean. And there is an open access contribution that is presenting these health indicators. And Here there is an example, which I already introduced to you, is the physical activity hours lost. And this is an estimate for China of the average hours of safe physical activity lost per person per day due to high heat index. And the contribution you see is very recent, is 2022. And here you see a progress from 2000 to 2021. And it is what you expect, that people lost some hours of physical activity. And there is a baseline, which is the long-term average, and there is a trend line. The trend line actually is not very representative of the trend, but indeed there is a trend, okay? And remember, the trend line is a linear approximation, and the linear approximation sometimes may be not very reliable. In this case, what I see here is a series of up and downs that are probably related to the fact that in some of the years they had a higher temperature, but there is a lot of variability. So the trend line, I'm not sure if it is really significant, but anyway, we can see a trend, and we can see a map over China, and different colors means light yellow is less than hour and per day, per person, and then for increasing darkness of the red, you have an increasing number of hours lost, and of course in the south you see that they had more problems because it's warmer. The Lancet Countdown for China is provided this map, which it is related to China, and it is related to, by comparing with the historical baseline average, which is the central circle. So you see, for any region, you have a trend. And the historical baseline is the center of the circle, the white circle of each indicator. This indicator is, let me see, if there is heat-wave related mortality, heat-related labor capacity loss, heat-related physical activity, different colors. And for each color, they show the increase in the last year of this health indicator with respect to the baseline average, long-term average. And so the cone refers to the whole population. The circle refers to over 65. So you can get a visual representation of health indicators they selected, and for each region, the increase in the last year with respect to the long-term average for the global population and for the elder people. So this is, I think, a relevant source of information. And basing on these health determinants, you can associate then the projected increase of temperature to the health outcome. And basing on the health determinants, you can find a support for estimating vulnerability. And then the exposure is a different story, because the exposure is related to the damage that you get from it. Of course, we are not discussing in detail how from the health determinant to get to the estimate of vulnerability, which is a number between 0 and 1. And there could be different methods depending on the kind of disease, depending on the climatic impact that you are considering. But the concept is that the health determinant may be a very good support, a very useful support to the estimation of vulnerability. And in fact, here they also present, in this contribution, very recent again, related to the Lancet Countdown, they also provide an interpretation of the representativeness of health indicators, relevance, robustness, whether the estimation is reliable or not, reproducibility, and timeliness. Timeliness means if it is calculated regularly the health indicator. And again, every year, the Lancet Countdown presents to you values for several regions over the world of the health indicators recorded for the last year. And therefore, you can really get an estimate of how vulnerability is increasing in this way. There are links in my web tutorials to the countdown. I also checked that this morning. There is already available, of course, we are in November, almost December. There is already the report for 2024 available, and you can get updated graphs like the ones that I showed you earlier that are not referred to the last report, but to the last but one. Now, let me see what else is interesting to say. I am skipping these further details on the Lancet Countdown because I don't think it adds more to your introduction to the subject, but I want to close with an introduction of other health indicators that are considered by GCOS, which is again a body of the United Nations. They are identifying in this visual diagram, which is an interactive diagram, which you can reach to the link that you see there. They are proposing and monitoring a number of health indicators related to climate. So it's something complementary to the work of the Lancet Countdown. And the United Nations, I think they are taking a climate-based approach, while Lancet probably is taking a health-based approach. But they are complementary, and they could give additional information and additional monitoring on how the health determinants are changing. And it's related to quantitative estimation. This is also an example of other climate indicator given by Copernicus. Copernicus is the European Health Observing System, and they also give climate indicators, health determinants, gives estimates and monitoring of health determinants. Given that they are climate-based, they are adopting a climate-based approach. They concentrate on climatic variables and not much on social health determinants. They are focusing on climatic health determinants. It's a complementary information, another kind of complementary information. And I think I may stop here because now I'm closing the lecture here and also in the tutorial with some identification of health benefits due to climate change. And but I think we already discussed it. I think it is not adding anything very significant. So how to close? First of all, I want to add a last take-home message. The take-home message is if you want to quantify what we discussed, you need a model. A model putting together the concepts that we discussed together. And this model must be a mathematical model and must be based by analytical relationship connecting climate, health determinants, or climate to health state, to health impact through health indicators, through states of the system, through policy intervention. And this model is to be constructed by relying on data and predictions of future climate, prediction of societal evolution. This is the last piece of the take-home message. Finally, I want to thank you for attending the lectures, as I said. And I must tell you, with respect to the last year, we were much more numerous, and this is great for a teacher. On the other hand, it makes the interaction more difficult. So I think that if you were only a few people, you would be probably more interacting with me. My suggestion for you is try to make an effort to be more interactive. Actually, you were responsive in a way, because when I teach, I look at your eyes and I could understand that, okay, there were up and downs, but still I couldn't understand your feedback. And my suggestion for you is, if I had to give a suggestion, is besides thanking you, is just to try to be even more active than that. So don't rely only on the body language. Speak up, because in your profession is extremely important, and in all the professions, but in your profession is extremely important. Speak up. Don't be shy, because you don't have any reason to be shy. Good. Thank you, and once again, contact me if you have any curiosity or whatever. I hope I met your expectation. If not, okay, at least you gained some information. Grazie. Yeah.
You mentioned something about climate change can be some
Yes.
I'm very interested in this stuff.
Okay.
Can you recommend that I read from anywhere specifically?
Okay. Can you please send me some references? Because now I don't have really the documentation ready. I take this opportunity to thank you, because I noticed that you were following what I was saying. And not everybody, arrivederci, not everybody followed, and I noticed that you were. So thank you very much. And send me an email. Okay? Yeah.